So I think this stuff is really confusing. So I made a little chart that kind of just like makes it make sense, because when you see all these things, they're all in different orders and different places. And I think lining it up in a certain way really kind of makes it all come together. All right, so here's what I have here. So these are the polyatomic Oxanions, okay? Specifically looking at what I like to call the eights, and I have an apple there to show that you're taking a bite, you're eating an apple, right? You ate the apple. Reminding myself that anions are negative, that's why I have a little negative there. And reminding myself that an onion, you know, is a non-metal. Onions are sad. This gas here, this balloon here is also, you know, a non-metal. So just kind of my ways to remember all that. So remember, what is an oxanion? It's a polyatomic anion containing oxygen. So everything in this chart you see contains oxygens. And I even have it, you know what, let's do this. Let's open this up here. All right. They end in ate or ite, okay. But I have some ides on here too, but I'll tell you why in a second. But because these eights are the most common, there's really no reason to memorize any of the ites, the hypos, the pers, or any of that other stuff. Really, if you memorize these 1, 2, 3, 4, 5, 6, 7, 8 green ones here, the eights, everything else is going to kind of fall into place, right? So what you do have to know, though, is just your per is going to mean 1 oxygen after your 8, okay? So you see chlorate as 3 oxygens, perchlorate is 4. And really, chlorate, bromate, iodate work exactly the same way. They are all in group 7A. They are all halogens, okay? And they're stable ion. They like to be -1, okay? And if you forget why that is, let's look at a periodic table and look at our Cl, our Br, and our I, right? We have our chlorine, our bromine, and our iodine. The way I remember that they're, well, first of all, they're in group 7A. Why their stable ion is -1, obviously, not obviously, but they want to lose an electron to become the noble gas that's next to them, right? Losing an electron, giving it a -1 charge, okay? Because you know this has 53 electrons. I'm sorry. Gaining an electron, which will give it that -1 charge. 53 to 54, 35 to 36, 17 to 18, okay? The way I remember that their 8 form has 3 oxygens is that they're in group 7, right? They're in group 7. And 7 to get to 10 is 3, all right? Bam. Chlorine, bromine, iodine. You could even say chlorine because it's 17, starts this chain. 17 and 3 is, 10 or 20. That's kind of how I remember that, by the group number here. That's why I even have the group 7. So boom, you're never going to forget that. Chlorine, bromine, iodine. They all work the same way. So you can use the same thing. You know that chloride, bromide, iodide, that's just your garden variety anion, right? You're adding an oxygen. You do perchlorate, perbromate, periodate. Remember, the 8 stays as you're increasing oxygens. As you're decreasing oxygens, you're going from 2 oxygens, 2 oxygens, 2 oxygens, okay? And look at the charge stays the same because your garden variety anion is just -1, -1. All of these the charge never changes, all right? All you have to remember is before 8 is ite. That's just kind of something that you have to remember. And then as you go to 1 before, so you're losing 1 oxygen, 3 to 2, and you're going from 2 to 1, you just have to put this hypo in there, okay? Hypo has an O in it. There's 1 oxygen. Maybe use that, O and O, to kind of remember that, you know? But remember, it keeps the ite. Everything to the left of your garden variety 8s here has an ite. Everything on the other side has an 8, okay? So there you go. So there's your Cl, your Br, and your I. Let's look at some of these other ones here. Sulfide and selenide, which are sulfur and selenium. Now, their charge is 2-. Go to our periodic table. Sulfur really wants to be argon, gaining 2 electrons, -2 charge. Selenium wants to become krypton, same thing. Everything in this column, in column 6A or 16, is going to have that -2 charge. I use the same thing that I did for the halogens here. They're in group 6. 6 and 4 is 10, or 16 and 4 is 20. They want to have 4 oxygens. So look at this. Sulfate, 4 oxygens. Selenate, 4 oxygens. That's the kind of confusing part, because all your 8s are not in the same column, right? Some of the 8s like to have 4 oxygens. That's how I remember sulfur and selenium. It's the same exact. If you can remember these 3, you're going to remember these 2, okay? And the charge stays the same. You're 2-, 2-, 2-. There are some holes here because I'm not exactly sure if there's other things in these columns, but still, you know that's an 8. When you get hit with a multiple choice question, you're gonna ace it, because you know the naming structure. You know sulfite is just gonna lose 1 oxygen, right? Now phosphate, I don't know why phosphate wants to be strange, because phosphate is in group 5 here, and it really doesn't use the same convention for my memorization. So I just kind of remember, you know what, phosphate's on its own. Phosphate really wants to be buddies with sulfur. PS, like a postscript, like you're writing a letter. I don't know, just kind of keep that together, P and S. And then you could say, okay, phosphorus is going to act the same way as sulfur, which is why we have 4 oxygens. Okay, just remember phosphorus is in group 5, which has a -3 charge. Remember, it wants 3 electrons to get to argon, okay? So same thing. If you remember phosphate, sulfate, and selenate, then you're good to go. You now know 3, 4, 5, you know 6 elements on the periodic table and their polyatomic oxanions, okay? Nitrate is one that you just kind of have to remember. Nitrate likes to have, you know, it wants 3 oxygens. So that's one that you just sort of have to, you know, remember. But I don't know. Hopefully this chart, putting this all together, seeing how things in the same groups are similar. These are all in the same groups. These are similar. Hopefully that kind of gives you some help.